Everyone, today we are starting a new unit, and we're going to start with an introduction to the kinetic molecular theory and some notes on temperature. So, before you begin the worksheet, there are a few introductory questions that I want you to answer. These will just get you thinking about some everyday phenomenon that are related to this unit with different phase changes, temperature, and heat. All right, so let's talk about temperature. So temperature, we'll define it as the measure of how hot or cold something is. It's also the average kinetic energy. So we measure temperature in 3 different units. 1 Fahrenheit, 2 Celsius is the metric standard, and then 3 in kelvins. In this class in particular, we're going to focus on these 2. We don't really use Fahrenheit outside of the United States, really. And it is useful, though, to talk about temperature casually when we're in the United States. All right, so we are going to do a few different kinds of example problems here involving some temperature conversions. So we've got a formula for Fahrenheit, a formula for Celsius, and a formula for Kelvin. So body temperature is 98.6 Fahrenheit. So what is this in Celsius? So I'm going to use this formula. 5/9 times Fahrenheit minus 32. So I'm just going to go ahead and plug in the numbers. 5/9 times 98.6 minus 32. So that'll give me still 5/9 times 66.6, and then I want to multiply by 5 and then divide by 9. So I end up getting 333 divided by 9. My final answer is going to be 37 degrees Celsius. Now, if I want kelvins, as we can see in this formula here, all I have to do is add 273 to that. So if I want kelvins, so this is one of my answers, and if I want my answer in Kelvin, I just add 273 and I get 310 Kelvin. Okay. So next, we have methanol boils at 75 degrees Celsius. What is this in Fahrenheit and Kelvin? So now we want to convert this to Fahrenheit, so I'm going to use this formula, 9/5 Celsius plus 32. So here we're actually going to multiply and divide before we add 32. So it becomes 9 times 75 divided by 5 plus 32. If we simplify those numbers, we get Fahrenheit equal to 135 plus 32. So we end up with 167 degrees Fahrenheit. It's pretty hot. And then, so to get Kelvin, again, we just add 273. So 75 plus 273, and we get 348 Kelvin. Okay, so practice using these equations. You'll get, again, there are 3 total, and you can see them here. All right. So 3 phases of matter: solid, liquid, and gas. How do we get from a solid to a liquid to a gas? Well, we can add heat. So if we add heat, imagine an ice cube, right? If you add heat to an ice cube, it'll melt into a liquid, water. If you add heat to liquid water, eventually it'll boil into water vapor. And so what we're doing when we add heat is we're actually causing the particles to move faster. They become more fluid, right? So we know that liquids have more particle movement than solids, and then gases have the most particle movement. So what exactly is heat? Heat is simply energy that's being transferred between 2 different objects at different temperatures. And so you can add heat or we can remove heat. When we add heat, particles tend to move faster, when we remove heat, particles will move slower. So this will take us to the kinetic molecular theory. And so what that states is that, and we're not going to talk about plasma really, different states of matter depend on the particle movement. So more energy, more particle movement is related to liquids and gases. So again, kinetic molecular theory basically says that all particles, all matter, is in constant motion. So again, motion means movement. Okay. The amount of movement or motion depends on the temperature, right? So if we increase the temperature, we're going to get more movement. So if something is hot, the particles will move faster. If something is cold, the particles will move slower. So that's a key idea that we're going to think about in this semester and this unit. Okay, lastly, I want to introduce you to this term. Absolute zero is the coldest possible temperature. It's 0 Kelvin, so really easy to remember, 0 Kelvin. You don't have to really remember the Celsius or Fahrenheit, but theoretically, this is the temperature at which molecular motion would actually completely stop. So if you're interested in this subject, you can see that scientists are still researching absolute zero. But that's it for this